Hi, in this lesson I am going to show you how to simplify rational expressions. But before we get to that, I'd like you to just pause the video and simplify those three fractions right there. Welcome back. So I'm going to show you how to simplify these. I look at a fraction like this and I look for common factors, and when I see this, I see both of the 60 and the 42 have a common factor of 6. So really what I'm doing is I'm dividing the numerator and the denominator both by 6. And when I do that, I end up with 10 over 7. So I have simplified that fraction. In my second example, I again look for those common factors. 2 and a 2, 2 divided by 2 is 1. Essentially, they divide out. 5 and 5, common factors, those will divide out as well. So when I look at this, all that's left now is the 3/7. When I get into when it has variables in it, again, common factors, so the c's are common factors, and this goes back to simplifying expressions that have exponents. So I have a c to the third, c to the first. Remember, we get to subtract. 3 minus 1 is 2, so I have c to the second in the numerator. The j's, 5 minus 4, that will put me at 1, so I'll have j to the first in the numerator. And with the r's, I'm going to do 8 minus 2, but now that is going to end up in the denominator because there's more r's down there, and I have r to the sixth. Now my next ones, I just want to work on factoring. So I want you to, again, pause the video and factor those three polynomials. Welcome back. So when I factor these, I'm going to look for a common factor in both terms in the first one. So this first one, I noticed that they both have a common factor of 5, but they also have a factor of h. So I'm going to factor the 5h out of both terms. And when I factor 5h out of 5h squared, h is left, minus factor of 5h out of 10h, and we're left with 2. So I have the two factors here of 5h and then h minus 2. Some could call that three factors, 5 being a factor, h being a factor, and then the h minus 2 being a factor. My next one, I'm going to factor, I have a trinomial here. Many times when we factor a trinomial, it will factor to two binomials. So that's how I'm going to start thinking. And remember, when we have a trinomial like this where there's a 1 in front of the squared variable, then we're going to have a w and a w at the beginning of our two binomials. And then we can focus on the 12. What times what is 12? But also, remember, adds together to be -7. Well, if it's going to add to be a negative, that means they both have to be negative. And a negative times a negative is a positive, so that's good. And then, well, 4 times 3, or -4 times -3 is 12. But when I add those two numbers together, I get -7. I have my factors. If I were to FOIL that back together, I'd be right back at the orange. And then my last polynomial here, another trinomial. This one is a guess and check one. So remember, we're going to look at the 21m squared and ask ourselves, well, what times what is 21m squared? I would guess 7m and 3m. And then I'd look back here at the -10. I go, well, what times what is -10? I might start with -5 and a +2. There's my guess. Now remember, here's where we have to check. So we have to look at the outsides and the insides. So if I multiply my outsides together, I get 14m. Multiply my insides together, I'd get -15m. Add those together, and I end up with -1m. That does not match right here. So that didn't work. So I come over and I try again. I'm going to stick with my 7m and my 3m for that guess. I'm going to stick with the 5 and the 2, but I'm going to switch them around. Let's try the -2 here and the +5 here. So now when I multiply my outsides and my insides, now I have 35m and then a -6m. And when I add those together, I get 29m, which matches that. Therefore, remember, these are the two factors of that pink polynomial. These are not, because it didn't check out. Now, the reason that we went through those is because when we go to simplifying our rational expressions, which are just fractions with polynomials in the numerator and the denominator. I look at this and I go, what do I do? Well, very similar to when we simplified these fractions. We looked for common factors. So I come here and I go, well, I need common factors, but I don't see the factors right now. So the first thing I have to do is I have to factor. So I'm going to take that numerator and I'm going to factor it. I'm going to make my two binomials. So I'm going to have an x and an x. Well, what times what is 14, but adds together to be -9? That would be -2 and -7. I got to factor my denominator, x and x. So now I ask, what times what is -35, but adds to be -2. So that would be -7 and +5. And now I have my factors. So when I look at this, if I have a common factor in the numerator and the denominator, they'll divide out and become 1. So I see x minus 7 and x minus 7. Those will divide out and become 1. All that's left then is x minus 2 over x plus 5. And I have simplified that original blue rational expression. Now I have another example here. Same concept. I'm going to factor my numerator. And in this one, I notice that 2z is a factor of both. And if I factor the 2z out of the first term, all that's left is the z. I factor 2z out of the second one, all that's left will be 4. Now my denominator, I have the difference of two squares there. Remembering back to our factoring days, z and z, one has to be positive, one has to be negative, 4 and 4. Now, look for those common factors. I see z minus 4 is in the numerator and the denominator. Those will divide out, become 1. Therefore, all that's left then in the numerator is 2z, and in the denominator we have the z plus 4. So I've taken that original red rational expression and simplified it to this black rational expression. And one more example. Again, concept doesn't change whatsoever. We're going to factor our numerator. I'm going to have, b's in the first spot. Now, what times what is -18, but adds up to be -7? That would be a -9 and a +2. And my denominator, I notice that 3 is a factor of both of them. And if I factor the 3 out, then I'm going to be left with v minus 9. And now I see that I have v minus 9 in both the numerator and the denominator. So all that remains is v plus 2 over 3 is my simplified rational expression. And that's going to conclude my lesson on simplifying rational expressions.